Hello, my name is Francesco, and today I'm going to present assignment 7. This presentation will consist in part 1, in which I will state my name, I will describe my contribution, and I will demonstrate the project running. And I'm going to show a screen capture of the project running and while narrating. And then in part 2 of the video, I will show all the code in a Word document, and I will discuss line by line what my code does. So first of all, let's go to the assignment itself, and yeah, so we are here, and I'm gonna show the project running. And well, I wanted to explain something first. So yeah, essentially, what this project is about is initializing a window from a 3D perspective that draws a cube with each face having a different color, and it continuously updates what you see in a loop, so the cube is always seen. And then in terms of our specific task, the code not only allows you to rotate using the keys, but it also, what we did is we implemented mouse control. So when you press and hold the left button of the mouse, and drag your mouse, it changes the cube's rotation angles. So in terms of the angle X and Y. And this gives a more intuitive way to interact with the cube, and it's honestly way smoother than using the arrow keys in the keyboard. So yeah, now I will show the project running. So for this, I will start with this and then go with that. Sweet. So here we have the cube. It looks like it's just a cube. I mean, it looks like it's just a square. However, then I press it, you start seeing different faces, and I can drag and move it around everywhere at very high speeds. But yeah, so we have 3 faces here, 3 faces here, 3 faces here, 3 faces here, 3 here, 3 here. Then yeah, we've seen all the colors: yellow, green, pink, red, light blue, and blue. Yep, perfectly working. So yep, we saw it working. So now, we demonstrated project running. I described my contribution specifically. Oh, okay. So, my contribution, more precisely to what I did, was making the user interaction smoother and ensuring that everything looks right. I added an I streamlined the callback cleanup with a static import, and I set up a mouse button listener that only responds when the left mouse button is pressed, and this way dragging is enabled to rotate the cube pretty much. And I used the temporary memory stack to manage short-lived memory needs. All of this while I established a solid 3D perspective by defining the field of view and clipping planes. Yeah, so in this way the scene gets rendered with the right amount of depth in order to appreciate it the best way. So now that satisfies my personal contributions. So now for the part 2, I'm going to go to a Word doc, and I'm going to describe line by line what my code does. So the red is for my teammates, the yellow is for me. Well, first we have the import statement, and this just allows me to use GLFW free callbacks method without always writing its full class name. It's a pretty neat trick in Java static import. It just makes the code cleaner, especially since we'll be freeing up our callbacks later when the window is closed. So yeah, just for that. Then for this line right here, here what I'm doing is I'm setting up a listener for mouse button events on the window. This means that every time that I click a button, the lambda function that allows um, the lambda function that gets called with details about which function was pressed and what kind of action occurred, like if it's been pressed or if it's been released, and any modifier keys that might have been held down. Then for the if line, this is checking to see if the mouse button event came from the left button. Since, I mean, the mouse typically has more than one button, like right, middle, left. But we're only interested in the left one, which is the one that's typically used for clicking and dragging. Then for the dragging line, here what I did is set up the dragging flag. So if the left mouse button is pressed, then dragging becomes true, meaning that the program should start tracking mouse movement to rotate the cube. When the button isn't pressed, it turns false, stopping any rotation updates based on the mouse movement. Then for this line, the try line, this creates a temporary memory stack using try with resources block. And the best way I can think of this is like a scratch pad for memory allocations that you only need for a short period. The cool part about this is that everything allocated here is automatically cleaned up once you exit the block, and this helps manage memory a little bit better. And finally, for this line, this call sets up the perspective for the 3D scene that we just saw before. It defines a 45-degree field of view, 1:1 aspect ratio, meaning that the view is square, and the near and far clipping planes at 0.1 and 100 units, respectively. So like one for near, the other one for far. And what this does essentially tells OpenGL how to transform the 3D scene into a 2D image on the screen, because I mean, of course, we're seeing all of this on the screen. And it makes sure that the objects are, the cube pretty much is rendered with proper depth and perspective, kind of getting the 3D effect. And yeah, that was it for today. And thank you so much.